Okay, so let's talk about a vertically launched object. While talking about one of those things, something that's shot up in the air, there's some things that you need to understand. The first thing is we're going to consider it to start on the ground, meaning your initial position, y0, is going to be 0 meters. Okay, remember you can change your reference point or your frame of reference, but we're just going to consider the ground 0. Okay? The next thing you need to remember is that just like in free fall motion, the acceleration is constant and it will always remain -10. The object will not stop accelerating, no matter what. You also need to remember that your initial velocity is your launch velocity, and whatever velocity you start with is going to remain your initial velocity through the whole problem. Also, make sure you understand that once the object is launched, it no longer has any other force acting on it except for gravity, which means it does not have an engine anymore acting on it. So a rocket ship doesn't count until the engine is turned off, okay? So let's think of more like a cannonball or something like that that's just thrown up right up in the air, okay? Or a ball. So the path of the object is going to go up, and eventually it stops, changes directions, and comes back down. Now, in real life, the object doesn't go up and then scoot over and then come down. This is just for visual purposes, okay? So where I start is y0, and that's 0 meters. The maximum height is my y max, okay? Now, let's talk about what happens to the object on the way up. On the way up, I have a positive velocity. I have a negative acceleration. If my velocity is positive and my acceleration is negative, then I know the object is slowing down. That should make sense. Okay? As it goes up, it slows down and reaches its maximum height. At its maximum height, the velocity is 0. The object stops. It doesn't stop for very long. So if you do this in real life, you don't actually see the object stop moving, but it momentarily does stop, okay? It changes direction and then comes back down. On the way down, the object has a negative velocity and a negative acceleration, so you know when that happens, the object is speeding up. That should make sense. All throughout this trip, the velocities are going to be equal and opposite at every point, okay? So if I start with a velocity of positive 50 meters per second, then I know that when I hit the ground, I'm going to end with a negative 50 meters per second. All right? And that's when y equals 0. Okay, just so you remember, they're equal and opposite of each other. Always will be. Okay? The time it takes to get to the maximum height is equal to the time it takes to get all the way back down to the ground. So now let's take this problem and solve for some missing variables. Let's start with how long does it take for the object to reach the maximum height? Okay, so find the t for y max. What else? I would like you to find what is y max. Okay, so those are the two things that we're going to focus on right now. So let's start with part A. Okay, in A, I know that I have an initial velocity of 50 meters per second. I know my acceleration is negative 10 meters per second squared. I also know my initial position is 0. And I also know that when I reach my maximum height, my velocity is going to be 0. Okay, remember we said once it reaches its maximum height, it stops. So if I'm looking for the time it takes to reach that, I'm not going to need the position that I have, right? I'm only going to use the velocities and the acceleration. We're going to use equation number 3. Okay, plugging in the values that you are given and leaving the variable for what you are solving.